Now, let us discuss the electrical instruments. So, what are electrical instruments? Basically, in physics lab, we are going to deal with some of the electrical devices. For practical circuits, these instruments are used. So, let us understand how these instruments works and what are the calculations attached to it. First is the ammeter. So, what is ammeter? First is, so it is an instrument used to measure the current, and it has to be put in series with the branch in which the current is to be measured. So first thing is like it has to be put in series, means you have to, it has to be part of the branch in which you are measuring the current. Now, an ideal ammeter has zero resistance, because if it is not having zero resistance, then branch resistance of the branch will change, and eventually we will say that the entire current value in the circuit will change. Now, this is how it looks like in lab. So there are, like, you can see a black and two red connections. So we just have to, if this is the wire, then we break the wire from here, and one wire has to be connected over here and the other has to be connected either over here or over here. So if you are taking over here, it's written that, so there are two scales. If you see that 1, 2, there are like two types of different scales. So here, like, if you are connecting over here, the something over here can be will be written, which you can see, and like whether to check this above scale or the bottom scale, that depends on which red pin we are using. Now, if we talk about the symbol, so this is the symbol for an ammeter. It's just a circle, we write A in it, which says that it is an ammeter. And if we go into the depth, like what is inside an ammeter, so if we talk about inside an ammeter, so this box is basically my ammeter, and inside that there is a galvanometer. Galvanometer is a similar instrument to ammeter, and galvanometer is again used to measure the current. It measures the current, but we will discuss in detail what is an galvanometer. So inside an ammeter, we can see a galvanometer, and there is a resistance which is connected in parallel to that, and this whole system is known as an ammeter. Now, conversion of a galvanometer into an ammeter. We have already seen that we just connect a resistance, and this is a resistance S, and this S is called the shunt. Okay, so we have to connect a shunt resistance in parallel to a galvanometer, and everything inside this is basically my ammeter. Now, this is the branch through which capital I current is coming, and some of that current will go into galvanometer. So we say that current in the galvanometer is represented by Ig. Ig is current in the galvanometer, and this is the rest of the current will pass through this shunt resistance. And now this shunt resistance has a property that it has to be very, very small generally, so that maximum current passes through this branch. So a small resistance is introduced in parallel to convert a galvanometer into ammeter. What is the calculation behind it? Let's see that. So here the amount of current total coming is I, and we will say that the galvanometer has a resistance G, and I am just saying potential difference between these 2 points. Either you can write IR, which is basically Ig into G. G is the resistance of the galvanometer, Ig is the current in the galvanometer. Now, here rest of the current I minus Ig into S. So this I minus Ig, I into R, S. So resistance is nothing but S. S is the shunt resistance. If we solve this equation for S, then we get this equation. So this is how we know how much has to be the shunt resistance if we want to convert an galvanometer into a wanted ammeter. So here, let us, what is I? If someone is saying that make a ammeter which measures 10 ampere. So basically we will say we want this to be 10 ampere. So maximum reading of that ammeter will be 10 ampere. And then we are utilizing a galvanometer which is having a maximum reading of just, let's say, 5 milliampere. Okay, and so this is also 5 milliampere, and what is G? G is the resistance of that galvanometer which is inbuilt, and this is also like generally inbuilt that this Ig and G, these two are the property of the galvanometer. Once we solve this equation, we know G, and we solve this equation, we will get the value of that shunt resistance. If we introduce this equal to shunt resistance in parallel to this galvanometer, then we will get a ammeter which will show us the reading that is equal to 10 ampere. So maximum reading can be 10 ampere for that particular ammeter. Now let us discuss this question, and this question says find the reading of ammeter. Is this current through the 6 ohm? First, is this the current through the 6 ohm? So whatever is the reading of this ammeter is not the current through the 6 ohm, because this ammeter is basically, see, what is the normal symbol for ammeter? We just write A, right? So if we don't write this 3 ohm, then this is an ideal ammeter which is having zero resistance, right? If we don't write anything, but since 3 ohm is written over here, that implies that the ammeter itself is having 3 ohm resistor, and now it will behave as a normal resistor like this. So let there be a current, and there will be some other current in this 6 ohm resistor. If we want to get the current through 6 ohm, then ammeter needs to be connected over here. Then only we can get the current through the 6 ohm if it is connected, if ammeter is connected in series with the 6 ohm. Here it is connected in parallel. So answer for this is no. And now let us calculate the reading of ammeter. So what is the reading of ammeter? Ammeter measures the current passing through it. Okay. So here it will give the reading of this much current. So for that, what I am going to do is, I am going to solve this circuit normally, and I just have to get the current in that branch, and that is also the reading of this ammeter. So first, this 3 ohm and 6 ohm are in parallel. So I'll just write 1 by R is 1 by 6 plus 1 by 3. That will give me that these two is basically 2 ohm resistor, right? These two combined resistance is 2 ohm, 2 ohm and this 1 ohm. So total resistance of this circuit is simply 3 ohm. And now this 3 ohm, and what is the total voltage in the circuit? Like total voltage in the circuit is 18 volts. So I'm just applying V is equal to IR, and my current is nothing but V by R. Here V is 18 volt and the resistance, total resistance is 3 ohm, and that gives me 6 ampere current. So 6 ampere current is flowing through the battery. Now this will get splitted into these two branches, and again will merge, and 6 ampere will pass through this 1 ohm as well. Now there are two options. One is get the potential difference across this combination. So for that, what is the potential difference across this 1 ohm? So we know the current in this 1 ohm is 6 ampere. So potential difference is I into R. So I is 6 and R is basically 1. So 6 volt is there. Now 18 volt is total, out of that 6 volt is across that. So here must be 12 voltage. Once we have the potential difference 12 volt across each of them. So I want this current, I am calling it I1. So my current, I can simply write that I1 into R, and resistance of that ammeter is 3 ohm, is nothing but that 12 volt. And that gives me the I1 is nothing but 12 by 3. So 4 ampere. What does that mean? Out of 6 ampere, 4 ampere is going in that branch, and rest of the 2 ampere is going in the other branch. And this is also the reading of that ammeter. So ammeter will tell that reading is 4 ampere. Now, by the way, that is not the current in this 6 ohm that we have already discussed. Now, next question says that find the current in the circuit. So similarly, we just have to treat the ammeter as a normal resistance, and I will say that current in the entire circuit is same as the reading of the ammeter, and current is V. I'm just applying V is equal to IR again. So total voltage is basically 10 volt. The current I have to find, and the total resistance is basically 2 and plus half ohm, because this and this is in series. So I'll say it is 2.5 ohm. And that gives me that I is equal to 4 ampere. So here also the reading of this ammeter is 4 ampere, which is also the current in the entire circuit. Now next we are going to discuss the voltmeter. So voltmeter is another instrument, and it is used to find the potential difference. Potential difference across what? Across 2 points in the circuit. So basically voltmeter also has 2 connections. And this is how it really looks like. So suppose there is a resistance like this, and you want to get the potential difference across this resistor, basically the potential difference across this point and this point. So you just take a wire, one connection is done over here and the other connection can be done over here. If you see again, same way, like there is 3 means you have to read from this scale, and 15 means if you are doing this connection over here means the reading has to be taken as per the scale over as per the 15 voltage scale. Okay, so this is just like this works as 2 of the voltmeters simultaneously, and in this here, as you can see, it is measuring the potential difference across where these 2 connections are given. So it measures the potential difference across any of the resistances or any of 2 points. Now for this is connected in parallel. If you see this is connection in parallel. So this is shown over here that this is the resistance and this is a voltmeter is connected. Now voltmeter symbol is simply V. Yeah, so we just make a round and we write V in it. And if you see what is a voltmeter, so inside a voltmeter again there is a galvanometer and there is another resistance, and this entire combination is basically my galvanometer plus a resistance in series is my voltmeter, which is shown over here. This entire thing is the voltmeter. Inside the voltmeter again there is a galvanometer and a resistance, but this resistance is not called the shunt. So to convert, a galvanometer can be used as ammeter also and as a voltmeter also. Like ammeter and voltmeter, both the devices consist a galvanometer, which we are going to discuss. Now it is essential that resistance RV of a voltmeter, this is the resistance, RV is called the resistance of a voltmeter. It has to be very large compared to the resistance of any circuit element. Like it has to be, RV has to be very greater than this resistance, because if that is not happening, then what will happen? Then the current which is passing in the original circuit, so some of the current will choose this branch as well. So we want this current to be 0. For that, resistance has to be infinity. So for an ideal voltmeter, the current, the resistance of an ideal voltmeter has to be infinity, so that it does not take or give any amount of current. It does not take any amount of current from the original circuit. So original circuit remains unaffected. Now RV has to be way greater than R, and for ideal ammeter it has to be almost infinity. So infinity is not possible. So practically we keep very large value of resistances. Now the working is again very simple. We are just going to see what does it tell. It tells the potential difference across these 2 points. And what is the potential difference? It is basically I into R. So current in this is the same as Ig, because that same amount of current has to pass through the galvanometer also. So it is basically I in, what is resistance? Resistance is resistance of the galvanometer plus this resistance. So G plus RV, and this is the voltage reading which this is going to provide. Now if we want like to get the value of RV, how much RV we have to connect. So if we want maximum reading to be V volt, this is again fixed, that how much current, how much is the maximum current which can pass through the galvanometer, and what is the resistance of galvanometer. So these two things are fixed. So if we want a particular reading, then we can choose our RV as per this formula. So it will give you the how much resistance has to be connected in series with the voltmeter, so that you can get a particular maximum reading. So Ig is the maximum reading of galvanometer and V is the maximum reading of now the entire voltmeter. Now let us see this question. This question says find the potential difference across the resistance 300 ohm in A. So this is the A and there is basically 300 ohm, and they are saying what is the potential difference across it. For that I am simply finding the current first. For finding current I am finding total resistance. Total resistance, these two are in basically series, so total will be 500 ohm. And now I am finding the current. So current is basically V by R. So potential difference is 100 volt by R, which is 500. So this is the value of current, and again potential difference across 300 ohm is nothing but current in that 300 ohm, which is same as the current. So same amount of current is passing through entire thing. So current is basically this into R, and what is the resistance? 300. So now I can simply solve like this, and answer is going to be 3 by 5, that is 300 by 5, that is 60 volt. So basically out of this 100 volt, 60 volt is potential difference across 300, and rest of the 40 volt is the potential difference across that 200 ohm. Now what will happen if we are connecting a voltmeter in parallel? See here, voltmeter connection is proper, voltmeter has to be. So I just want to measure the potential difference across this 300 ohm and I put a voltmeter, but the problem is this voltmeter is having 600 ohm resistance. So ideally it has to be very large when compared to 300, but 600 is not very large when compared to 300. So I cannot neglect over here. So I have to calculate properly, and now they are saying again find the potential difference across this 300 ohm resistance. So here treat this as a normal resistance. Now, again, what is the total resistance? Resistance of these two combined is basically 1 by 300 plus 1 by 600 and reciprocal of that. So we will get the parallel combination, resistance of parallel combination as 200 ohm. And if this entire 200 ohm is combined with that, then total resistance of the entire circuit is basically 400 ohm. That is 200 plus 200 in series. Now, I am finding the current. So current is basically V by R and V is again 100 and resistance, the entire resistance is basically 400. That gives me 1 by 4 ampere. So from here 1 by 4 ampere current is basically going. So here the current has to split. So what I am going to do is I have to get the potential difference across these 2 points, or potential difference across this or this is the same. So that is what I need to get. What I am going to do is I am finding the potential difference across this 200 ohm. So what is the potential difference across 200 ohm? That is the current in 200 ohm, that is 1/4 ampere, and resistance of 200 ohm. So we get 50 volt. Now 50 volt has been utilized by 200 ohm. So the rest of the 50 volt will be the potential difference across this or this. Now what is voltmeter reading? Voltmeter is also reading that 50 volt. So remember the last case the actual potential difference across this 300 ohm was 60 volt. But since we have put a voltmeter which is not ideal, it has changed the reading completely, and now the new reading is simply 50 volts. So potential difference across 300 ohm in this case is basically just 100 minus 50. You can write like this, and this is again 50 volt. So ideally the voltmeter should have infinite resistance, otherwise it is going to alter the circuit.